Okay, guys. Today we're gonna talk about chapter seven, and then in here we're gonna start with 7.1, types of linear system and their graphs. Okay, so let's start with um, page 216 uh, first. So system of linear equation. Um, this is an example of a system of two linear equation. So, um, so you can see that for each um, linear equation here, you have two linear equation, then we call it like system of two linear equation, and we should have two unknowns in this case for solving these two linear equation, which is x and y, right? So um, a solutions in this case has to be in an order pair as x0 or y, x0 and y0, which specifies for each equation. So a question that is negative 3, 0 a solution for this system. How to answer this one? We're gonna substitute these two order pairs into the system and see what happens. So I have 3 times x. X now is negative 3 and y now is 0. So negative 3 plus 5 times 0 equal to negative 9. And then for the second equation, you have to substitute the same. Negative 3 plus 4 times 0 equal to negative 10. So as you can see, if you simplify both to this linear equation, the top gonna be negative 9 equal to negative 9, which is okay. That means it's satisfied. But what about the second one? It's gonna be negative 3 equal to negative 10. Then that should be should be like no way to have that, because negative 3 will never equal to negative 10. So that means what? The negative 3, 0 will not be a solution. So say no, is not, right? Okay, now let's answer the second question, which is 2 and negative 3 a solution. Again, 2 in this case 2 is x and negative 3 is y. So I'm gonna substitute into the function, that's, I mean the system. So 3 times 2 plus 5 times negative 3 equal to negative 9, and then 2 plus 4 times negative 3 equal to negative 10. Okay, now let's simplify for each equation. The first one, left hand side gonna be um, 6 plus with negative 15, which is negative 9, equal to negative 9. That is good. The second one gonna be 2 plus with negative 12, that's gonna be negative 10, equal to negative 10. So that also satisfied. So that means this is a solution. Is And the third one say graph to verify the solution. Okay. Um, if you you want to grab it, you can start with the rectangular system here. Is x, is y. Okay. For the first equation, 3x plus 5y equal to -9. Um, if you have, let's say, try to find the x-intercept of the first one. X-intercept will be y equals 0. So you put y equals 0 in here, right? Y equals 0 in here. Then this will be negative. It will be 3x equal to -9, and that will give you x equal to -3 if you divide by 3 both inside. Okay, so you have -3, 0 for the x-intercept. What about the y-intercept for this equation? So you push 0 into x, right? So let me delete this so we have more space to go on this. So now you have the first term is gone because 3 have 0, right? The second term is 5y equal to -9. So that's going to give you -9/5. If you divide both sides by 5, that's going to be -9. Okay, so that means what? That means you have -3 and the x-intercept should be here, and -9/5 will be use a calculator. So -1.8 is 1 is 2 is 1.8 is around here. Okay, so then you will have like a line go through these 2 points. Okay, and that is for the first equation here. What about the second one? So x-intercept will be in the case as y equals 0. So you have x equal to -10, right? Y equals 0, then 4 times 0 will be 0. So then that's will be -10, 0 for the x-intercept. Then y-intercept for this one, I can clean this up. And now for y-intercept, you need x equals 0, so this term is gone, and y will be equal to -10 divided by 4, and that will give you -2.5. Okay, so -2.5 and 0 and -2.5 are going to be the y-intercept. So x-intercept is -10 is should be let me use that. Okay, so is 3, 4, 5, 6, 7, 8, 9, and 10. So this is -10. That's for the x-intercept. For the y-intercept is -2.5. So -2.5 should be around here. And then you're gonna draw the line, go through these 2 points. And these 2 lines will intersect each other around here. So in order to verify the solution by graphing, you might have to estimate that at here, at this point, let me use the green one. At the intersection point, what is coordinate of it? So let's see. I think because my drawing is not really well, so it's not as 2. It should be 2, right? So maybe I should draw. That's okay, good. Oh, that's better. Um, and I will delete this guy. That's better. All right. So it's better now. So hope is good. So then now we have the intersection is here. So it look like it's V2 and then 3. And that's going to be the solution. Okay. Um, so a solution to the system of linear equation must satisfy all the equations. And in this course, we mainly deal with the system of linear equations that have exact one solution. Okay. It could have 3 cases that it could be one solution only, no solution, and uh, infinite solution. Okay. So mostly, mainly in this class, we're gonna talk about the case with one solution or no solution. Okay. So now, let's we gonna delete this and go to the move back to the example 2. Okay. So, all right. So here is example 2. We're gonna try to solve the following system of linear equation by graphing. Okay. So So graphing this one again, you have to find x-intercept and y-intercept uh, for each equation. First one, so you say x-intercept. What is it gonna be? You cross this, you have y equal to -8, right? So sorry, x-intercept that make y equal 0. So cos y, so now you have 2x plus uh, plus 0 equal to -8. Then you're gonna have x equal to -8 divided by 2 is -4. So I have -4 0 is x-intercept. For the y-intercept, let me delete this. And then for the y-intercept, you need to make the x equal 0, right? So x equals 0, then you have y equal to -8. So then -0 and -8 gonna be y-intercept. That is for the first equation. What about the second one? If I have x-intercept, that's what is it gonna be? You put 0 for y, then x equal to -1, right? So now, if x equal to -1, then you have x is going to be -1 comma 0, and then y-intercept, what is that going to be? It's just gonna come back with the original equation and put 0 for x, and then you have 0 minus y equals to -1. So then you have y equals to 1 if you multiply by -1 both inside, right? So you're gonna have 1 for the y-intercept, 0 1. Okay, so let's go down here and graph for the first one. So the first one, I have x-intercept is -4, so put -4, and y-intercept is -8. 1 2 3 4 5. Oh, I must should have -8. So maybe I'm gonna split a little bit. Okay, let's say -1 2 3 4. So here's -4. Doesn't matter. So just gonna say here's -4 1 2 3 4 -4 here, and then -8. So I put here is -1. I make the scale different for the y. So 1 2 3 4 5 6 7 8. Here's -8. -8 here. Okay, so now you will have um, the graph for the first equation is a line go through these 2 points. Oh, this one. Okay, so that is for the first one, and now I'm gonna try for the second one. So the second one have actually set is -1, and y-intercept is 0 1 0 and 1. So if I want to draw a line go through these 2 points, and if it say solve this following system by graphing, you just gonna look at the graph here and see the solution will be the intersection point here. The coordinate of this intersection which is -3 and -1. No, -2, because we have different scale here. So that's be -3, -2. Gonna be the solution. So it could be almost I'm gonna say it could be approximately because when you see my graphic, it sometimes it have some error because you cannot see like is that gonna be -1.99999 something like that next to -2. So that's why graphing method just gonna help you to mainly is for approximate the solution. So solution in this case gonna be -3 and -2. Okay, and that's gonna be the solution. So now let's move down. All right. So here we're gonna talk about the type of linear system. Okay. So we have totally 3 types of linear system. The first case is an independent system, which has exactly one solution. Okay, and I stated before, if you have 3 cases for how many solutions for a system. Usually it's have to have only one solution or no solution or have infinitely many solutions. Okay, so there's 3 cases only. So for the case that has exactly one solution, we call independent system. Okay, so so you can take a look at the graph here. The 2 lines have only one intersection. That's gonna be independent system, and it has exactly one solution. Okay, the second one, you see that the 2 lines are parallel each other, right? And then they don't have any intersection point. So then there's no solution at all for this system. So then we call inconsistent system. Okay. And lastly, the third case is the case that 2 lines they are overlap each other, like they lie on each other. So in this case, they have like infinite many solutions, and and all they can call it the lines are coincident. Okay, and they are the same line, and so every coordinate pair on the line is a solution to both equations. And in this case, we call this is a dependent system. Okay. Okay. Example. Let's solve the following system of linear equation. Okay. So this okay, for this problem, we cannot, if they don't allow you, if they don't tell you that you going to use graphing method, you must use algebra method. And for the algebra method, let me note it. So for the algebra method, you have only two ways. One is elimination, and the other one is substitution to solve this problem. Okay, for this problem, you actually can do either way to solve it for this problem. So let me show you by using substitution first. For the substitutions, you should choose an equation that you can isolate a variable easily. For example, in this case, you can choose the second one. That's fine. From this second one, you must to isolate the equation, the one variable here. So the easiest variable to isolate in here is y, because you're gonna add x both hand side. So we're gonna give you y equal to -1 plus x. So what? Now you know that y equal to -1 plus x. So using this one, use y equal to -1 plus x and substitute back into excuse me, equation number 1. Let's say here is equation 1, here is equation 2. We have, okay. So remember that if you use the second equation to isolate, then that's isolate had to be substituted into the other equation. Okay, that is why I did use the second one to isolate the y. So now I have to apply and substitute it into the first one. Okay. So now what do I have? I'm gonna have 2x plus y, right? Plus y. But y now is this guy. So I'm gonna write as -1 plus x and equal to 8. Okay. So time to simplify the left hand side. I'm gonna have 2x here combined with the x here gonna be 3x, and then -1 equal to 8. So now you're gonna have what? You're gonna have add both hand side by 1, and you will have 3x equal to 9. And then it divide both hand side by 3, then you will get x equal to 3. That is for the value of x. Okay, so so you should know that the answer solution in here, what I estimate from graphic method is gonna be 3,2, but because they don't allow you to use graphic method, then you must find the order pair for the solution by using substitution method in this case. So in here I did find it's x equal to 3. Now I'm gonna need to find the y, right? So I change this become 3. Okay. So now how can I find y? Okay, remember that I did isolate y over here already, right? So I can use this value of x, substitute back into this isolate to get the answer of y. Okay, so y equal to -1 plus x, and it's going to be -1 plus 3. So then y gonna equal to 2. Okay, so that's gonna be exactly the answer that I estimate from graphical method. Okay, so that is substitution method. Um, Usually substitution method will apply for the case that mm, like not, you can solve the system by animation substitution for any case, right? But it will be easier if if you see an equation if you see an equation that have that easily that isolate easily a variable. So note that elimination, oh sorry, substitution method will be easy if the system has an equation that 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 has isolated a variable array. So for example, a system such as say x equal to y plus 1, and the other one is 2x plus 3y equal to 5, right? So then you can right away use this guy, substitute into the second one to get to get the y value, the only one the one equation that have only one variable is y, and solve it. So so that's a note that you should know. But anyway, if you see that the system that can easily isolate the variable, then you can still apply the substitution. Um, so okay, so let me move down to the next page. I'm gonna clear this up. Okay. um, this is number 3, and you can also, the problem is also asking us to solve the following system to the linear equation. According to the graph here, you can see that the two equation, two line here is look like parallel each other. So look like this system doesn't have any solution. But who knows? Maybe later on it's keep going finally and it's touching it like right here. But in order to make sure that it is no solution, we need to solve it by algebraic method. So so in this case, you see that both, I mean, both variable in up to equation in left hand side, right? So similar with example two, you see both variable. Say first one, the first equation here have x and y in the left hand side, and the second one also in the left hand side. So note both x, y up to equation in left hand side, right? That's one thing. So in this case, um, usually if you see both of them in left hand side, you can think about using elimination method. Okay, and how that work? So you will actually take the first equation, you subtract for the whole second equation. What does that mean? Okay, so let's have x plus 2y equal to 9, and here x 2y equal to 13. And if I subtract for all of this, right? So you see that why I do this? Because I try to eliminate. When you use eliminate method, you're gonna try to have one variable that have try to make one variable that have the same coefficient. So and then eliminate it. That means you subtract it. So then it's gone, and then it's left with the other variable, and later on you can solve it easily. But anyway, let's see what happened. So if you subtract it, now it's look like this. The left hand side will be top one, we have still x plus 2y, right? And you subtract for this, that means it's going to be all change the side. So minus x and then minus 2y. Now equal to top still have 9, so 9, and minus for 13 because the 13 now we change to be negative, right? Okay, so finally you will simplify. So left hand side you have x and negative x gone, 2y and then 2y gone. So you have 0 in the left hand side, and you have 9 minus 13. What is it going to be? Negative 4. And you see that 0 equal to negative 4 is a true? Not true. Okay? So then no solution. If an equation that never become true, then you want to say no solution. Okay? So that is the reason why when you look at the look at the graph here, the line look like parallel each other. Okay, so that is one thing. So let's move down. Let's see what's going on. Actually, you can also using substitution for this, right? How to use substitution? Just gonna isolate. Say here's one, here's two. Isolate one of them. Let's choose the first one. So which variable you should isolate? I'm gonna say x because you just substitute. You're just gonna minus 2y both hand side. So that can be x equal to 9 minus 2y. Okay, easily. So now you will have use this one. Use x equal to 9 minus 2y. Substitute into the second equation. So I have x now become 9 minus 2y plus 2y equal to 13. Okay, time to simplify. You have minus 2y and 2y, that's gone. So then you have 9 equal to 13. Oh, 9 equal to 13? Not true. So then you can say no solution. Okay? So I just show you two methods. And I would say the substitution method is always work. And I mean, if you don't want to focus on eliminations method, you can always use substitution. Okay. All right. So let's move down. And I'm gonna clean this up. And now we have number 4. Okay. Again, we want to solve the following system of linear equation. I would say I will show you by substitution first, and later on I'm going to show you by elimination, because both the variable is on the left hand side up to this equation, so I can still use elimination. But I'll show you later. Okay? Maybe I'm going to have two boxes here for substitution. Firstly, you need to isolate one of them. So here's number 1, here's number 2, and you will isolate x, or x equal to 2 minus 3y easily. So you're gonna substitute x equal to 2 minus 3y into number 2 equation. So then you have 3 times x minus 2y, 2 minus 3y minus 3y plus 9y equal 6. Okay, so now you're gonna have do distribution, right? So 9, no, not 9, sorry, 6 minus 9y, and then plus 9y equal to 6. And then now you will cancel negative 9y with positive 9y, and you will have only 6 equal to 6. This means what? All the way true. What does that mean, always choose? It means what? Always correct. And as I'm gonna say, infinitely many solutions. Okay. So So that means the two lie on each other. See here, it actually is one line on it. So that is using substitution. Okay, what about if I use elimination to solve this problem? So x plus 3y equal to 2, and the other one is 3x plus 9y equal to 6. Okay, um, firstly, which variable that I want to eliminate. I'm gonna say I would like to eliminate the x. Okay, let's say x. And in order to do that, I need to make two equations have the same coefficient. So what does that mean? Uh, that means I need to take the first equation here and multiply by 3. Then I will have 3x at the same as 3x for the second one. So I will have 3x plus 3y, 3x plus 9y equal to 6. And then 3x plus 9y equal to 6. Now the system look like this. And you can easily see that they are the same equation, right? And if you now you subtract both of them, you're gonna say, oh, 3x minus 3x 0, 9y minus 9y 0, and 6 minus 6 0. Then what does that mean? 0 equals 0. And you're gonna say always choose. And that means what? Infinite many solutions. Okay, so that's gonna be two ways for you to choose to solve this problem. But again, I'm still gonna say, oh, just gonna choose substitution, because substitution will help you to handle any case, even if it's isolate already or not isolate. Okay, so it's always gonna be work. But elimination, you need it. You need both hand side have to have. I mean, the both equation have to have x y and have to have variable on one hand side, is the left hand side, and then you can do that. Okay, so um, let's we move to the next one, and I'm gonna play this up. Okay, linear equation. A restaurant serves two types of fish dinner: small for $5, okay, and large for $8.99. Small for $5.99. Okay. So yesterday there were 134 total order of fish. We total received 1,024.66. Okay, so how many small and how many large fish dinner was ordered? So we need to set up two equations in two unknown, where S is number of small dinner. So F is small and L is large dinner, right? We solve it there. So let's say um, we have two equations. Um, we have total is 134 total order of fish, right? So what does it mean? We have small orders, like number of small orders, adding with number of large orders will be equal to 134. Because this is total orders, right? And total receipt is this. So you want to think about how much you earn for small order, how much you received for small order. So small, each one is about 5.99. So you have S number of order small. So that's 5.99 S plus with 8.99 for each large order. So L is the number of large order. That will be 1024.66. Okay, so this easily will give you two equation or a system of two equation, two linear equation. Then you need to solve it. So how to solve it? You wait a second. They say set up only, and we solve it later. Okay. So yes. So here is the answer. Okay. This one should be the answer. So let's see if down here they want us to solve it. No, they don't need us to solve it. But anyway, that should be the answer. Okay. Now come to this column. Um, Companies that make 52-inch HD TVs are willing to produce more TVs if they can sell them at higher price. So the supply of TVs is also a function of the price at which these TVs will sell. Suppose that the supply equation is x equal to 0.375p plus 460. Okay, and where x is supply measured in thousands of TVs, and suppose the price demand equation is x equal to 1720 minus 0.50p. So is there a price where the demand equal the supply? And so you should understand that the supply equation is this guy, right? And the demand equation is this guy. So if they say, is there a price where the demand equation equals the supply? It means what? Um, it's also called equilibrium price, like the price that that make the price and that make the demand and the supply at equal each other. So then it's actually gonna be the solution of the system x equals to 0.375p plus 460 and x equal to 1720 minus 0.50p. And for this case, you need to solve this problem by substitution only. Because why? Because the variable is like on both hand side, right? P in right hand side, X is in the left hand side. So you can choose either the first one or a second one to substitute in the other. So I'm gonna say let's choose the first one, substitute into the second one. Okay, so I will have now x, this x become this guy, right? So I will have 0.375p plus 460 equal to 1720 minus 0.5p. Okay, so we have the equation that have only one variable. So I will add both ends side by 0.5p, and now I'm going to have 0.875p plus 460 equal to 1720. Now I'm gonna subtract both ends side by 460. What do I have? Okay, so you can use a calculator to do this one. So essentially you're gonna be 0, 6, and then 2, and then 1. That will give me 0.875p. Okay, so now you're gonna divide both inside by 0.875. So you're gonna have p equal to, left side gonna be p. I'm gonna use my calculator to solve this one. Okay. So I have 1260 and divided by 0.875. Enter. And then I have p equal to 1440, $1,440. That's going to be the price. That's demand's going to be equal to the supply, or the equilibrium price. Okay. And in that case is because we need only the price, but we don't need the number of x. So I would just I'm just gonna say the price is this. If they ask for the number of the x, like the supply gonna be how many, then I'm gonna just substitute this p into one of these equation to get the x. So okay, let's move down to see what is next. All right. Okay, so this page is actually telling us to solve the equation, the system equation that I just showed you. Okay, so actually in this one they also ask us for having the demands and supply, so you need also to find x. So let's say x equal to 1720 minus 0.5, p now become 1440. So that's going to be equal to, use your calculator. So you have 1720 minus for, using minus for 0.5 times with parentheses 1440 and close parentheses and enter. So you have 1000 items. So it's gonna be 1000. Okay. So so when you answer in here, after solving, you're gonna put like the price where supply equal demand is 1000 demands, and the equilibrium price is, say, x equals this and p equals to 1440 $. So I think I need to come back with the problem that about here. For the small and large dinner, fish dinner, because it look like it doesn't we don't have to solve it. So I will come back and show you like how to set up a table first, and then later on you're gonna have you're gonna have to you're gonna have a system of equation easier. So firstly, we are talking we're gonna have a table, okay, that maybe you're gonna have to split this. The column down here will have two sides. So one is small and one is large. Okay, and then the row here is going to talk about price. So, or maybe I'm gonna just do this. I'm gonna have here the, so for the small size you have the price for H1, H small one gonna be no, I mess up with this. Let me up. I need to use a table. Okay, so we did have one talking about the total orders. Okay, so let's say the first column is talk about number of order. So you know that total for number of order gonna be 134. And then the small one, let's say here's small and here's large. Okay, now it's better. So for the small one, you have S. Number of small one is S, and the number of large one is L. And the second one is talk about the receipt or the price. So for the price of the small one, you're going to have to use S here, which is number of order. You multiply with the price of it, so 5.99 times S. And then similarly for the large, it's going to be 8.99 L. And the receipt going to be 1020 24.66. So from table, you can have two equation, which is S plus L equal to 134, and the second one is 5.99 S plus with 8.99 L equal to 1024.66. So this will be the system of equation that you need to look for, and we don't have to solve it. Okay, so let's move down to the next two page. Okay. So this we done. This also done, and come to this part, this one. Okay, so come back with the problem of TVs. We in this page is telling us that can we also solve it by graphically. So I have two equation graph two graph of the two equation here. So is intersection gonna be the solutions? This is 1000 and 1440, but according to the graphically, you cannot see clearly for the price. Value. So you can see that if you use the solution by algebraically, it should be 1440. So p equal to 1440. But because in here we are just looking by eyes, so we cannot see it clearly. And so weak line is graph of price demand. Okay, so let's come back with the graph of price demand. What is that gonna be? So the price demand equation was 1720 minus 0.5 p. 1720. So 1720. So it was x equal to 1720 minus 0.5 p, right? So firstly, you need to notice that this 1720 gonna be the the y-intercept. So look like this guy, and also the slope in here. Slope is negative, so it decreasing. So then this should be the graph, the decreasing graph here should be the price demand, graph. Okay. So what are the coordinates of the x-intercept, and what do they refer to the business context? So actually in here we don't have the variable y, so we actually using x-intercept here, right? So for the x-intercept here, it was x-intercept 0720, and it's telling us that at price is 0, at price is 0, we're gonna have we're gonna have we have demand at x equal to 1720 units or items. Okay, so I have just finished section 7.1, and go ahead and do the XYZ homework and the assignment that due on Tuesday, and I want to see you in the class next week. Okay.